Hey guys, today we're going to talk about the Pythagorean theorem. So this is a new topic for us. The Pythagorean theorem, it is something that has to deal with triangles, and in particular with right triangles. So triangles that have a right angle. So in order to introduce this theorem, we need to kind of talk about special parts of right triangles first. So before we talk about this nice little theorem, what it gives us, we're just going to talk about right triangles. So right triangles we know are triangles, like this is triangle XYZ, that have a right angle. So whenever you have a right triangle, you have certain parts of it. So in a right triangle there's one right angle and there's two acute angles. Angle Y and angle Z are acute angles. So the longest side of a right triangle is the side that's like across from the right angle. So like YZ is the longest side here. And in a right triangle it has a special name that's called the hypotenuse. The hypotenuse. So the hypotenuse is the longest side. Now the other two sides, the two sides that together where they intersect make the right angle, they're also the smaller two sides. So YX and YZ. Those are the smaller two sides, and together, where they intersect, they make the right angle. These are called the legs of a right triangle. And these are all going to be important terms for the Pythagorean theorem. So the legs are the smaller two sides, they make the right angle, and the hypotenuse is the side across from the right angle. So like down here, if this was our right angle, then this would be a leg, this would be a leg, and this would be the hypotenuse. Or if let's say we had something like this, if this was your right angle up here, then this would be a leg, this would be a leg, and over here would be the hypotenuse across from the right angle. Knowing all of these terms is going to be really important for Pythagorean theorem. So Pythagorean theorem really looks into a relationship with triangles. Instead of looking at the angles, we look at the lengths of the sides. So let's draw a triangle, a right triangle. And we're going to look at the lengths of the sides. So we're no longer talking about the angles, we're talking about how long this side is, how long this side is, and how long that side is. We're actually measuring the length of the sides. And the Pythagorean theorem, well, there's a special relationship here. If you take the length of this side, which we'll call A, and you square it, and you add that to the length of the other leg over here. So if you add the lengths of the two legs squared, A squared plus B squared, then that equals the length of the hypotenuse squared. And this is what Pythagorean theorem is. You add the lengths of the legs squared, so these are the legs, and you have to square them. We'll see some examples. That equals the length of the hypotenuse squared. And we'll see some examples with this, but this is the big equation to know for Pythagorean theorem. And how we can use this is if we know two of these three, if we know A, B, or if we know A and B, or A and C, or B and C, if we know two out of the three, then we can find the missing one. So all we need is two lengths and we can find the missing length in a right triangle. So our first question we want to do is we want to find, here's our right angle down here. We know this is 9 inches down here, this is 12 inches, and this is X inches. And our goal is to find the length of this here. So we need to kind of think of what we have. We're going to use the formula, A squared plus B squared equals C squared. But if we look at the right triangle, we have the 9 inches, well that's a leg, so we'll say A is 9, and the 12 inches we're given, that's also a leg, so we'll call that B. And we're trying to find X, which is the hypotenuse here. So we don't know what C is. C is X. And all we're going to do is substitute in. 9 squared plus 12 squared equals, well, we don't know what it is, it's X squared. And for these, it's good to know your perfect squares, but 81 is 9 squared, plus 144, that's 12 squared, equals, we don't know what x is yet, so we'll write x squared. When you combine your like terms here, you get 225 equals x squared. And now if we think back to way back earlier in the year, x squared is 225. So to figure out what x is, we're going to need to take the square root of 225, and that'll tell us what x is. So what number squared gives us 225? And when you do the calculation here, you'll find out x is 15. So the missing side is 15 inches. So we know this length is 15 inches. That's how Pythagorean theorem works. So let's try another one. We'll keep that up there. So now we have a right triangle like this. We know this is x feet, this is 10 feet, and this is 16 feet. We are trying to find, well, we have 16, that's one of our legs. 10, that's another one of the legs. And we're looking for the hypotenuse. So again, we're going to put in 16 for A, 10 in for B. So 16 squared plus 10 squared equals our x value squared, because x is the hypotenuse here. So 16 squared, we should end up getting 256. 10 squared, we should end up getting 100. So you're going to end up with 356 equals x squared. Now for this, you're going to need a calculator. So 356, we're going to round answers if they're not perfect squares to the nearest tenth. So when you take the square root, 356, that'll give you x. And when you put this in a calculator, if we round to the nearest tenth, it's 18.867, so it would round to 18.9. That is what x is going to be equal to. So it's 18.9, and we're in the unit of feet. So to take the square root here, you get 18.9. On your calculator, or you can look one up online, the square root symbol looks like this. When you type it, it might look like this actually, and you'll type in the number here. So for this one, it was 356, then you would close it out. You'd be taking the square root of that number. So square root of 356, and that'll get you the 18.9 here. Let's look at another example. We'll do two more. So we'll leave our Pythagorean theorem up here. So here we have this triangle, looks like this. Have a right angle down here. We are told this is 8 meters, this length is 24 meters, and this length up top is x meters. So if we look, the 8, well, that's one of the two sides that makes the right angle, so that's one of the legs. So the A is 8, we'll say. B, well, B is actually over here, it's the other leg, and that's x. So we're missing one of the legs, but we do have the hypotenuse here. So we're going to go to our formula, a squared, which is 8, so 8 squared, plus, we don't know what b is, so we're going to put an x in for b, and that is equal to, well, we know the hypotenuse is 24, so it's 24 squared. Now we do a little bit of calculating here, so 8 squared we should know is 64, plus x squared equals, well, 24 squared is 576. Then you're going to subtract your 64 from both sides. You want to get x by itself. So x squared equals, when you subtract, you get 512. So that means x is equal to the square root of 512. And again, we'll round to the nearest tenth. So when you round this, x is going to be equal to 22.627. So it rounds to 22.6. We're in the units of meters. So I'll put in meters there, and we're all done. I will do one more of these together, and then you can try some on your own. So our last one here, we have a triangle that looks like this. The key thing with these is recognizing what your hypotenuse is, what your legs are, and which ones you have and which ones you're looking for. So here's our given information. So to find your legs, look for your right angle and which two sides make the right angle. So one of our legs is 17. The other leg we don't know is x. So again, we have one leg, we're missing one leg, but we do have the hypotenuse here, which is 20. So it's a little tougher to see that the hypotenuse is down here, but it's whatever's across from the right angle. So we have one leg and the hypotenuse. We're trying to find the other leg. So let's go to our formula. 17 squared plus x squared is equal to 20 squared. And now we're just calculating. So 17 squared, we end up with 289 plus, we don't know x yet, so plus x squared is equal to 20 squared is 400. So when you subtract, you get x squared is equal to, subtract 289 from both sides, you get x squared is equal to 111. And if we round, because we're going to have to take the square root here, so x is equal to square root of 111. When you round this, you get x is equal to 10 point, we'll round to the nearest tenth, so 10.5, and we have centimeters. So that's our value of x here. Again, it's just really about recognizing which sides are the legs, which side's the hypotenuse. It needs to be a right triangle, but then we can use this nice theorem. So if you're feeling okay with them, you can go on and practice some for yourself. If you're still feeling a little iffy, I'll go through 3 more problems with you. They're on the last slide here, and you can try them on your own and then check your answer with what I get. So our first one, if you're doing those 3, first one, we have this triangle. And we have, this is C inches, this is 5 inches, and this is 12 inches. Actually, sorry, this is x inches. So here, let's see what we have. Well, look where your right angle is. So the right angle, the 2 sides that make up the right angle are your legs. So we're given both of the legs. One is 5, one is 12. And these you could switch back and forth, that's fine. They're just going to switch places over here. But the hypotenuse, you have to have the right value. And in this case, we don't know what the hypotenuse is, it's x. That's the last side across from the right angle. So we know 5 squared plus 12 squared, those are your 2 legs, equals the hypotenuse squared. Hypotenuse we don't know. So here we get 25 plus 144 equals x squared. When you combine your like terms here, you get 169 equals x squared. To isolate your x, you take the square root. And then when you take the square root, you end up with x is equal to, well, we should get 13 for this. And we're in the units of inches, so x equals 13 inches. And there's your value of x. So that was our first one. Our second one, we deal with some numbers that are a little bit larger. But if you have a calculator, it's not too bad. Just gotta type numbers in. So here's our second one. We are told this is 51 yards up here. This is 60 yards over here. And this is x yards. And we're given that's the right angle. So for this one, let's see. We're going to figure out A, B, and C. Well, the legs are what make your right angle. So one of them is 51. The other one, we don't know. We'll call it x. And the hypotenuse is across from the right angle. So your C is 60 here. So let's just plug in 51 squared plus, we don't know what this leg is, so plus x squared equals 60 squared. So 51 squared, when you calculate, make a little line here, you get 2,601 plus x squared is equal to 60 squared, you should get 3,060. So we get, or sorry, 3,600, not 60. And then let's do a little subtraction. So x squared is going to equal, when you subtract, you should get 999. So you have square root of 999. That'll give you what x is. And x is equal to, we'll round to the nearest tenth, 31.6. And we're in the units of yards. So there we go. There's your value of x. That's your B. That's the other leg here. And if you wanted to check your answers, you simply could plug this in to the formula that you have. You could do 51 squared plus 31.6 squared, and then take the square root of that, or just square the 60 and see if it equals that. You can plug everything in and see if it makes the equation work. If it does, then you have the correct answer. All right, on to our last one, and then you can go try some of these on your own. So our last one, we have this right triangle. Again, these have to be right triangles for this theorem to work. We are told this is 8 meters, this is 18 meters, and this is x meters up here. So 8 meters is going to be one of our legs. The other leg, we don't know. These two sides are the legs. So the other leg, we don't know, it's x. And the hypotenuse, well, that's going to be 18 here. That's the side across from the right angle. So if we plug in 8 squared plus x squared equals 18 squared, so when we calculate, should get 64 plus x squared equals 324. Now we're just trying to isolate x, so subtract your 64 from both sides, and x squared should equal 260. Again, to get rid of the squared, you have to take the square root of both sides. So you're going to have x is equal to the square root of 260. And if we round to the nearest tenth here, x would be equal to 16.1 unit of meters. So meters, and we're all done. And that was the missing leg that we were finding there. Alright, so go ahead and try some of these on your own. Key thing is listing what you know, because then you can plug into the equation and solve for what you need to find. Alright guys, have a nice day.